please open to page 260 in your student journal. Today we're going to continue graphing our quadratic functions. Remember, quadratic function means the highest exponent on the variable is a 2. When we graph our quadratic function, the shape of the graph is called a parabola. It is that nice U-shaped graph that we've been working with the last couple sections. So far, when we've been graphing our parabolas, we've had the transformations of a vertical stretch, a vertical compression or shrink, a vertical reflection, and we've had a vertical translation, which means our graph would move up or down. Today we're going to focus on the last transformation we will cover with quadratics. And let's take a look at letter A to see what that transformation is going to be. We start with our parent function, which is just our plain old f of x equals x squared. Again, that is the same thing as if we had a y equals there. We've graphed this one a few times already, but I will sketch a quick XY chart for you. So we substitute our values in for x squared. We square -1. Remember, we do get +1. We put 0 in and square it, we get 0. 1 in and square it, we get 1. So if we just do a quick little sketch of our graph, if we want a few more points, I know we've put -2 and +2 in before. We square 2 or -2, and the result is 4. So if we just want a couple more points on our graph, we can. Just have a better idea of what this looks like. Now the second function that we want to graph, we now have an x minus 2, but notice that x minus 2 is in parentheses being squared. Last time we looked at x squared minus 2. These are two different functions. Notice the minus 2 in the first one is not being squared. This is what we did last time. This minus 2 is inside the parentheses. It's part of the term that's being squared. So that's what we're going to focus on. So let's try to set up our XY chart, and I'm going to put -1, 0, and 1. I'm going to make a little bit bigger chart because I'm not sure what's going to happen with this graph. So let's substitute -1 in. So we have -1 minus 2, and we square that. We need to do the parentheses first. So we end up with -3 squared. And I know some of us have been getting the incorrect answer when we put something like -3 squared in our calculator. You do need to put the parentheses around that before you square it. Whenever you square a number, the result should be positive. Minus 2. Square that. 0 minus 2 is -2. Again, we square any number, the result is positive. Let's substitute 1 minus 2, -1. We square that and we get 1. Now with all of our other graphs, whenever we put -1, 0, and 1 in for x, our graph was symmetric. So -1, we got 9. Our other graphs, if we put 1 in, we also would have gotten 9. But now this one's a little bit different. So we're going to have to extend our chart a little bit and see if we can figure out where the heck this vertex is. Where is our graph going to be symmetric? So let's go ahead and let's go with the positives. I know the positives are easier to work with. So let's go in the positive direction first. Let's substitute 2 in. So 2 minus 2, I'm going to square that. 2 minus 2 is 0. 0 squared is 0. Still don't have any type of pattern yet in my y values. I'm looking for possible symmetry. So let's try 3. Let's just try a couple more positives, then we might have to go negative. We put 3 in for x. 3 minus 2 is 1. 1 squared is 1. Well, there we go. Now we have a 1 repeated. Let's go one more value. Let's put a 4 in for x. 4 minus 2 is 2. 2 squared is 4. There we go. Now we can see our symmetry. Here's a 1 and a 1, and a 4 and a 4. Now we have our pattern, which means that middle point, there's our vertex. So let's go ahead and graph x minus 2, quantity squared. So let's go to 2, 0. Then we have 1, 1. There's 3, 1. 0, 4. And 4, 4. There's our nice symmetric parabola. We could draw in the axis of symmetry. Goes right through our vertex. Nice time for us to just refresh. The axis of symmetry is the vertical line through the vertex. Since it's a line, if I'm asked for the axis of symmetry, I have to write an equation. I do need the x equals. I know some people on their 8.1 quizzes were missing the x equals for the axis of symmetry. And x in this case, along that whole vertical line, is 2. It's the same x value that we saw at our vertex. So now that we've graphed our function, what does subtracting 2 inside those parentheses, part of that squared term, what does that do? The purple graph and the red graph, they seem to be the same graph, just in different places. The red graph has really been moved to the right 2. The proper terminology or vocab is going to be a horizontal translation. And we move to the right 2. Just like with the vertical translations, the up and the down, I want you to be exposed to the proper terminology. I'm okay, though, if I ask you for the transformation and you just tell me that it's right 2. That's fine with me. So we subtracted 2 inside the parentheses that were being squared, and our graph moved to the right. Now let's turn to the next page, page 261. Let's look at letter A, and I need you to make this little change for me. Let's get rid of the negative signs. I want to keep these first ones as simple as possible for us, just focusing on the one transformation at a time. So we have our parent function, just plain old x squared. Again, get rid of that negative sign, just cross it out. And we graphed that one on the previous example, so I'm going to go ahead and just sketch that graph here. If you need the table for this, it's just right over on page 260. So there's plain old f of x equals x squared. On our last example, we subtracted 2 inside the parentheses, and we saw our graph move to the right. So if we do a little reasoning, if subtracting 2 caused it to go right, we might think maybe adding 2 might make it go the other way, which would be left. So let's set up just a little chart. I'll grab a different color here. Now, if we're thinking that our graph might go to the left 2, we don't want to set up -1, 0, and 1 for our x values. -1 and 0, they won't show us that nice curvy symmetric parabola. If we think our graph might be moving to the left 2 means -2. That's the number I want to put on my chart in the middle. That's where I think the middle of my graph, that vertex point, is going to be. Then I want to pick some numbers close to -2. So -3 and -1. Let's just start with those. Let's see if maybe we have this right, that it does go left. Maybe we'll see the symmetry with just those 3 x values. Let's start there. Let's start with substituting in -3. So we have -3 plus 2. That gets squared. -3 plus 2 is -1. -1 squared is 1. -2 is up next. -2 plus 2, we get a 0. 0 squared is 0. -1 plus 2 is 1. 1 squared is 1. It looks like we say this is our vertex. These two values are the same. Looks like we found our symmetry. Let's go ahead and graph these 3 points. -2 is at the middle, which would be our vertex. -3, 1. -1, 1. Those 3 points will give us a pretty good idea of what our graph looks like. And in fact, we were right. Adding 2 inside those parentheses did cause our graph to move to the left 2 places. So again, the vocab piece, horizontal translation, and we did go to the left 2. I am okay, again, if I ask you for the transformations, I'm okay if you just tell me left 2. Let's just do a little refresher again on the axis of symmetry. It is a vertical line, so we have to have the x equals. We need the equation to get a line. And all the x values along there are -2. Same value for x that we have at our vertex. Same value for x at the vertex, same value for your axis of symmetry. Let's go ahead and summarize our transformations. Let's go ahead and turn to page 263 in your student journal. And let's go ahead and summarize what we've learned with all of our transformations. Up at the top of page 263, you see graphing f of x equals, and then we have a whole bunch of variables in our quadratic. This is known as vertex form. The reason why it's known as vertex form is because we can identify the vertex without doing any work at all, using the transformations we've learned. So let's go ahead and take a minute and let's talk about those transformations with our vertex form. The a value, I want to start with the a value. If the a value is larger than 1, so if a is bigger than 1, we saw in section 8.1, it caused a vertical stretch. Our graph got skinnier. We stretched it out vertically. If our a was smaller than 1, we had our vertical shrink, or if you like the word compression, either one. And then whenever a is negative, that caused our vertical reflection. So this was our main focus. Letter A was our main focus in section 8.1. That was our main focus. The next variable that we see in vertex form is the letter h. It's inside the parentheses. It's part of the squared term. When we subtracted h, so when we had x minus h squared, we had a horizontal translation right h units. Then we saw that if we added inside the parentheses for that squared term, it was another horizontal translation, but it went to the left, h units. Now remember, don't let that h bother you. That will just be filled in with a number. So our number was 2 in the examples. We went right 2 units. We went left 2 units. The thing I do want to caution you on, I do want to highlight this for you. Subtracting caused our graph to go right. Adding caused our graph to go to the left. We graphed it. We set up the table. We graphed it ourselves. We saw that that happened in our first 2 examples. So when you're dealing with transformations, which way is my graph going to go? The minus in the parentheses really goes right. The addition in the parentheses really goes left. Just be careful with that. Our final piece is our k value. That is what we worked on in 8.2. If we're adding a value, if we're adding k, that caused a vertical translation up k units, and again, k will just be any number. If we subtracted k, we had a vertical translation down k units. Now, before I move on and talk about why this is vertex form, how we get our vertex from this, take a little pause here and make sure everybody in your group has all of this complete. So now, how do we use this information to find our vertex? Our vertex is that either lowest point on the graph, or if our graph opens down, it's the highest point. How we find that is using our translations. However far our graph goes left or right is going to give us the x value for our vertex. Our vertical translation, however far we move up and down, is going to give us the y value for our vertex. So our vertex point, if we look in the graph up above here, is listed as h comma k. This is our vertex. The h value is just how far we moved left or right. Remember, if you move left, it will be a negative. And our k value is just how many we moved up or down with our transformations. Remember, if you move down, that will be a negative value. So just be very careful when finding your vertex. Along with finding the vertex, you can also find your axis of symmetry. The axis of symmetry, remember, will be x equals, and it's just going to be whatever your h value is, which is how many units you move left or right for your transformation. Again, it's the same value that we had at our vertex point. So before we move on and apply this and start trying to look at transformations, finding our vertex and our axis of symmetry, again, take a pause here, make sure everybody in your group has a nice labeled graph. So now let's bring all of this together. Turn to page 264 in your student journal, and we're going to look at numbers 9 and 10. What I want to do first is identify any transformations that we may come across with our graph. I like to go left to right in my function, picking out the transformations. The first one I come across a 3 in front of my squared term. That 3 is bigger than 1, so it's going to cause a vertical stretch. The next thing I come across, I'm adding 2 inside the parentheses that are being squared. Remember, adding 2 caused our graph to go left 2. Now that we have our transformations, let's build ourselves just a small XY chart. And I know the last few sections we've been putting -1, 0, and 1 in for x, and it's worked beautifully for us. That works so well because our graph always just stayed on the y-axis. It didn't move away from it. We only moved our graph vertically, up or down. Now that our graph is moving left or right, now we have to stop and think about, where's the middle of my graph going to be? The middle of my graph has been moved to the left 2. So if I move to the left 2, that means the middle of my graph is now at -2. Since our graph is not moved up or down at all, my vertex will stay at 0 for the y. Now I want to pick some values for x that are close to -2. -3 would work, and -1 would also work very well. Let's substitute those values in for x, talk our way through the computation. Let's start with -3. We have to do what's inside the parentheses first. -3 plus 2 is -1. Exponents next. -1 squared is 1. 3 times 1 is 3. Now what should happen, if we have our vertex right, I'm just going to do a double check here. When I substitute -1 in for x, I should get the same thing that I got for -3. And we do. Here's my vertex, and this shows my graph is symmetric. Now, since our graph might be moving left or right, I like to find my values first. I like to make my chart first before I draw in my axes on the graph. -3, -1, I need to make sure those fit. And +3. -2, 0. -1, 1, 2, 3. -3, 1, 2, 3. And there's a little sketch of our graph. Again, here's our vertex at -2, 0. Axis of symmetry. Axis of symmetry. X equals, draw a little line here. X equals the same thing it does at the vertex, which is -2. What I would like you to do is just name for me the transformations for number 10. Just name for me the transformations in number 10. If you want to, before I do it, if you want to try to set up the values for x for your chart, you may do that as well. So just take a minute and try to find all the transformations in number 10. Whenever I find transformations, I like to work my way left to right on the graph. The first piece I come across is a negative sign. That negative sign causes our vertical reflection. So I know that my graph is going to be opening down. It's going to be flipped upside down. That's what that negative sign tells me. So if I find all my ordered pairs and I graph, and my graph doesn't flip upside down, it doesn't open down, I know I made a mistake finding my ordered pairs. The next piece we see is a 1/4. That 1/4 is smaller than 1, so we're going to have a vertical shrink, or a compression if you like that word better, if you've learned this before. Next piece we have a -6. And I'm going to go ahead and just take a second. I'm going to move my chart out of the way. We have a -6 inside the parentheses. Subtracting inside the parentheses causes my graph to go to the right, and in this case it'll be 6 units. Last but not least, the +4 on the end, that is not part of the squared term, it's just a plain old +4. It's going to cause my graph to go up 4. Once again, our standby -1, 0, and 1, they're not going to cut it for our graphs anymore. Now that we're starting to move them left and right, 0 is no longer going to be the middle of my graph. So I use my transformations to find my vertex, which will be the middle of my graph, the middle of my chart. My transformations tell me we go right 6, and we go up 4. So both of those will be positive numbers. Right 6, up 4, there's my vertex. Right 6, up 4, and I have my vertex. Now I want to pick some numbers close to 6. 5 would be a good choice, and so would 7. If you pick these numbers that are just 1 away from your vertex, all you have to do is the computation to find one of them, and you know the other. So let's substitute 5 in for x. In this one, the computation is going to be a little bit longer. Order of operations, I do what's in the parentheses first, so I end up with -1. Exponents are next. I square 1, I get +1. Multiply before I add, so I'm going to end up with 1/4 plus 4, which will just give me 4 1/4. So now when I go to draw my graph, I have to be able to fit 5, 6, and 7 on. If I don't have to change my scale, that usually makes things a little easier. If you always want to draw your graph the same and change the scale, you can. Since I have to fit 5, 6, and 7, I'm just going to scoot my graph over to the left. So now when I graph, I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Then I have 5, 4 1/4, so we go up just a little bit of a box. And then 7 we have 4 1/4 to match. And I lost my negative sign, guys. Sorry, I lost the negative sign on the 1/4. I lost the negative sign. Let's fix that. I might be thinking, Miss Golly, how did you know you lost that negative sign? I knew I lost the negative sign because my graph should have opened down, and if I would have connected those points, my graph was opening up. So if I have -1/4 plus 4, that means I have 3 3/4. So go over 5, up 1, 2, 3, 3/4, and then I have that mirror image of 7 3/4. So there we go, our graph opens down. Our graph has been moved to the right 6, up 4, and it has been reflected. This time I'd like you to try your progress check. You may use any of your notes on your progress check that you'd like.